First of all, everybody say hi.
Hi.
Okay, that's good.
This is the juniors.
Most of them, not the ones that are.
All
All right. So I have several questions that we're answering based on this function right here. So the first question is, what is the parent function? So if I wrote a function f of x is equal to 3 times x minus 4 squared plus 2, I'm pretty sure everybody would recognize that the parent function here is x squared, and that I have an a, an h, and a k. Yeah? Okay. So this one up here, it's the same kind of a thing, except that it's an exponential function. And so my parent function of this exponential function is 2 to the x. That's where I'm going to start from. And I have an a, an h, and a k. But I'm going to start from, that's my parent function, 2 to the x. So let's just pause right there. Okay, so we are agreed that 2 to the x is the parent function. So the next question is, tell me 3 points that you immediately know will be on the graph of the parent function. Basic exponential function. 0, 1, 1b, negative 1, 1 over b. I mean, those should just be ingrained in your memory. These are the 3 points that are going to be on every basic exponential function. So my b is my my base here, that's the 2. So I have 0.01, 1, 2, negative 1, 1 half. So when x is 0, this is going to be 2 to the 0, that's 1. When x is 1, that's going to be 2 to the first, that's 2. And when x is negative 1, that's going to be 1 over 2, 1 half. What I was saying is a number of people had the 0.24 when they were figuring out the 3 points. But the problem with 2,4 is this. Here's your graph of an exponential function. And you graph 0, 1, 1, 2, and then 2, 4. Yes, you're going to get in the shape of it, but the benefit of having the negative 1 is then you can begin to see that this is going to be along your horizontal asymptote of 0, that they're going to get to be smaller and smaller and smaller fractions. So that's one reason to do the negative 1. Okay, so the next question says, will there be a vertical asymptote for the transformed function? If so, what will it be? So here's kind of the, well, let's do it on a graph. Here we go. Next. Okay. So I'm graphing my parent function. You gotta wait through all this stuff on the video. Fast forward. Parent function 2 to the x. 0, 1, 1, 2, negative 1, 1 half. There's my graph. Okay. Will there be a vertical asymptote for the transform function? No. All exponential functions have a domain of negative infinity to positive infinity. All x values are okay with exponential functions. So there's no vertical asymptote, because a vertical asymptote would stop an x value. That means that can't be an x value. So no vertical asymptote. Will there be a horizontal asymptote for the transform function? Well, the transform function, that's my transform function when I do that. Will there be a horizontal asymptote? Well, when I'm just using my parent function here, I know that my horizontal asymptote is going to be y is equal to 0. It's going to be the x-axis. But what I'm doing with my transformation here is I'm going to be stretching it by a value of 3, which will not affect which will not affect my asymptote. I'm going to be shifting it to the right by 2. But if I shift it to the right, or to the left even, that's not going to affect any horizontal asymptote. But I'm also moving it up by 4. And that is going to affect the horizontal asymptote. Because everything that goes through this part of the function, the exponential part of the function that's stretched, everything that goes through that, when I'm finally done with those processes, then I have to add 4. So everything that would have been 0, or close to 0, is now going to be 4 higher. So I'm going to have a horizontal asymptote right there at y equals 4. Yes? No? Yes, we're good with that? Okay. Okay, then based on that, I can kind of answer the next ones pretty quickly. What is the domain of the transformed function? Well, I know that the transformed function is going to be, it's going to be a stretch of 3. It's going to be shifted to the right 2. So it's going to be a stretch. I don't know what it's going to look like. I know it's going to be, well, let's just kind of pick up. It's going to still go along here, somehow like that. It's going to be raised up by 4. It's going to be shifted to the right by 2. I don't know the exact points, and I don't have to graph it according to this problem. But the domain, I can see, is still going to be all real numbers. So the domain is still going to be negative infinity to positive infinity. That's not going to change when I shift when I do my transformation. Is everybody okay with that? I'm getting yeses. Okay, good. All right. What is the range of the transformed function? So my valid y values, right? Well, on my original function, my range was my horizontal asymptote. That was as low as I could possibly get, and it went up to infinity. Well, now my horizontal asymptote is raised by 4. So my range is going to be, my lowest y value is going to be 4, and that's not included, because that's an asymptote. And my highest y value is going to be infinity. So that is going to be the range of my transformed function, because I lifted that horizontal asymptote from the x-axis up to 4.